Okay, question 4, all about energy. Figure 7 shows a toy helicopter. The helicopter is powered by a battery. When it is switched on, a motor causes the blades to spin. This lifts the helicopter into the air and it flies around the room. Energy is transferred between different stores when the toy is used. Use the words from the box to complete the sentences. We've got thermal, sound, gravitational potential, electrical and magnetic. It's clearly an old question. Some things I don't like in there, but that's okay. Let's read through the paragraph. As the toy is used, the something energy store of the battery decreases. This energy is transferred to the motor, then to a something energy store in the spinning blades. As the toy accelerates upwards, its something energy store increases. Okay, so as the toy is used, the something energy store of the battery decreases. Keyword, battery. Batteries always have chemical energy. Wow, this is really old school. Electrical. If you got this question in an exam, let's double check that, you'd now be expected to put chemical. Yeah, okay, there we go. 4.1 should be chemical, it just appears not to be there. How odd. So it was chemical. This energy is transferred to the motor, then to a something energy store in the spinning blades. Key giveaway here, spinning, motor, you've got something moving, therefore you're going to have a kinetic energy store. As the toy accelerates upwards, its something energy store increases. What's the key word there? It is upwards. When something moves up, it gains gravitational potential energy. 4.2. Write down the equation that links energy transferred, power and time. Oh, how kind and Mark for remembering something. Power is the rate of energy transfer. So power equals energy transferred over time. Bear in mind, sometimes they give you that and it means the same thing. They sometimes say work done over time, and work done is just energy transferred as well. So they're synonyms, they mean the same thing, work done and energy transferred. I'm just going to mention here, so I'm going to refer to that as power equals energy over time here. P equals E over T. The toy can fly for 15 minutes before it needs to be recharged. The power output is 4.8 watts. Calculate the maximum energy stored by the battery. Let's take out the key values. So time equals 15 minutes. Stop, warning, alert, minutes. This is physics, we work in seconds. To convert minutes to seconds, do this straight away. 15 times 60 is 800 seconds. Now, what about the rest? The power output of the battery is 4.8 watts. So we're told power, P, is 4.8 watts. Calculate the maximum energy stored by the battery. Well, power is energy divided by time. I'm looking for the energy. So if I multiply both sides by time, I get energy equals power times time, as they cancel out on this side. In other words, power 4.8 times 800. Forgive me, I'm again going to have to use a calculator for this. 4.8 times 800 is going to be 3,840 joules. 3840 joules. Good. 4.4. Some energy is wasted as thermal energy or sound energy. What happens to the wasted energy? Always the answer, the wasted energy, is, lovely word this, dissipated, spread out to the thermal store of the surroundings. Learn that, repeat it. The wasted energy is dissipated to the thermal store of the surroundings. What does that mean? It heats up what's around it. Think of your laptop or computer running now. If you touch it, you will feel that it's probably quite warm, especially near the battery. That's what this line is telling us. Some energy is wasted heating up the surroundings, but we should say that wasted energy is dissipated to the thermal store of the surroundings. 4.5. A child used the toy when the battery was not fully charged. The battery supplied 3,200 joules of energy to the toy. 1,920 joules of energy was usefully transferred. Calculate the efficiency. Well, what percentage of energy was usefully transferred? So efficiency is going to be equal to the useful energy transferred, or the energy transferred usefully, divided by the total energy supplied. We can work that out by doing useful, which was 1,920, divided by the total energy, 3,200 joules. And that's going to give us 1,920 divided by 3,200. I'm getting 0.6. If, and that's a fine answer, you wanted to convert that to a percentage, you times it by 100, and that would be 60%. But 0.6 is fine. It didn't ask me for a percentage. It might. You wouldn't get marked down for giving a percentage, though. Give one way the efficiency of the toy could be increased. Well, what sort of toy was it? It was a helicopter, wasn't it? Typically, anything with moving parts, what you need to do is put oil on. So lubricate, and by that I mean add oil to, lubricate any moving parts. So those spinning blades, you've got friction slowing them down. If you put some oil on them or around the motor, that's going to waste less energy. This is less friction. Lubricate any moving parts. There we go. That's question 4 done.